Hello, welcome to lesson 6 on the topic time and work. In this lesson, we are going to get introduced to the concept of alternate work. So far, in all the examples that we have discussed, either people were working under some conditions or people were working together all the time. Now, in the concept of alternate work, this is called as the concept of alternate work. There is a definite pattern in which we will be working. Alright? Let me introduce this to you by taking a very simple example. A can complete a task in 10 days, whereas B can do it in 30 days. We have looked at the example in how much time will they do it together. But now the condition is A works on the first day, A will work on the first day, B will work on the second day, A will work on the third day, and so on. So can you see a pattern that is being followed? And we call it as the concept of alternate work. How will we do this? We will do it the same way that we have been doing attempting questions so far. We will take this as 30 units. So the efficiency of A will be 3 units. The efficiency of B will be 1 unit. Alright. What have we been saying? We have been saying so far that 4 units is completed in 1 day. Now we will say that 4 units will get completed in 2 days. Alright. So 4 units in 2 days, because on the first day A has contributed, on the second day B has contributed. Put together they have done 4 units in 2 days. Now please don't make a mistake of saying that this is same as 2 units per day. You cannot take the average. Why you cannot do so? Because on the first day 3 units is being done, on the second day 1 unit is being done. Put together we are able to do 4 units in 2 days, but that does not mean that we are doing 2 units every day. I hope you understand. So 4 units in 2 days. What is the next step? The next step is look for a multiple of 4 closest to 30. Don't cross 30. Look for a multiple of 4 closest to 30 but less than 30. So what is that multiple? That multiple is 7. 4 into 7 is 28. So 4 units in 2 days, therefore 28 units. I can call it as 7 cycles of 2 days each. Right? 7 cycles of 2 days each. 28 units will be completed in 14 days. Alright? 28 units will get completed in 14 days. Who is going to work on the 15th day? The person who started on the first day. Who is that? It is A. Now this is very interesting. So what is the efficiency of A? The efficiency of A is 3 units. But how much work is left? We have only 2 units remaining. Right? So therefore 30 units. That means the remaining 2 units will be completed by A in 2 by 3 days. 2 by 3 days. Now many students find it difficult to understand this 2 by 3. How and from where did we arrive at this 2 by 3? So please look at this again. How many units left to be completed after 28 units? 2 units. What is the efficiency of the person who is going to work? 3 units. So how much time will that person take? 2 by 3 days. So the work will get completed in 14 2 by 3 days. Now, an interesting observation. In questions of alternate work, my answer will actually depend on who started the work. Alright? So let me take the same data and instead of A beginning, The only change that I am making is B has started the work. Will the answer to the question change? Let's have a look. So what will be my approach? My approach will still be 30 units. This is 1 unit. This is 3 units. We'll continue to write it as 4 units in 2 days. Alright. So if it is 4 units in 2 days, therefore 28 units will get completed in 14 days. Who started the work? B started the work. Who is going to work on the 15th day? B will work on the 15th day. So, what is the efficiency of B? Now this is interesting. The efficiency of B is 1 unit. Therefore, 29 units will get completed in 15 days. Who is going to work on the 16th day? A is going to work. What is the efficiency? 3 units. How much work is remaining? 1 unit. Therefore, 30 units will get completed in 15, 1 by 3 days. That means, if you are listening to this question and the discussion very carefully, in the concept of alternate work, the answer to the question may depend on who started the work. If the person with the higher efficiency starts, the work will get completed earlier. And obviously, logically, if the person with the lower efficiency starts, the same work will take more time to get completed. Alright? Now, if you were listening to my statement carefully, I said that the answer may depend. I did not say the answer will depend. I am once again repeating, your answer may depend on who started the work. Some of you might be wondering what could be an example. Why am I making a statement that the answer may depend? Okay, let me present another example. And hopefully this will make it clear to all of us. What I'll do, A can complete a task in 20 days, B can do the same task in 30 days. They are working on alternate days. I have only changed the data. So what will be the approach? This will be 60 units, this will be 3 units, this will be 2 units. What you will write? You will write 5 units in 2 days. Okay, 5 units in 2 days. Alright. What is the next step? You have to go to a multiple of 5 closest to 60, less than or equal to 60. Is 60 an exact multiple? Absolutely. So 5 units in 2 days, therefore 60 units, that means I am talking about 12 cycles, will get completed in 12 into 2, that is 24 days. Now, this example of the concept of alternate work will not have 2 answers irrespective of who started the work. Alright. So what is the basis? What is the understanding? The logic must be clear to all of us. If I take each person's 1 day's work or 1 hour's work, add it up, and if it is a factor of the total, I repeat, if it happens to be a factor of the total, then the answer will not depend on who started the work. But if it is not a factor of the total and you still have some more days left, then that question will have more than one possible answers. This is an aspect which you must be careful while attempting the question on the concept of alternate work. Now, can this work if we are talking about more than 2 people? Can I have a concept or can I have an example of the concept of alternate work with say 3 people? Let's look at this example also. Alright, so what do I have? A can complete a task in 6 days, B can do it in 9 days, C can do it in 12 days. Alright, so A in 6 days, B in 9 days, and C in 12 days. Now what we'll do, we'll take this as 36 units. So 6 units, 4 units, and 3 units. 6 units, 4 units, and 3 units. Okay. So what is the situation? On the first day, A is going to work. On the second day, B is going to work. On the third day, C is going to work. On the fourth day, A is going to work. On the fifth day, B is going to work, and so on. So there is a pattern. Okay. So what we'll do? You have taken their individual efficiencies. Now when I combine everything together, I'll say 13 units in 3 days. Hope you are listening carefully. We'll say 13 units, 6 plus 4, 10, and 3, 13 units in 3 days. Alright. What is the next step? The next step is go to a multiple of 13 closest to 36, which is 26. Therefore, 26 units will get completed in 6 days. Another cycle. Who is going to work on the 7th day? A is going to work. So 7th day, A will work. So what we will do? 32 units in 7 days. 32 units in 7 days. Who is going to work on the 8th day? B is going to work. How much will B contribute? 4 units. How much work is left? 4 units. So 8th day, B will work. 36 units gets completed in 8 days. What is the answer to my question? 8 days. So students, in this lesson, we have looked at the concept of alternate work along with 2 examples to understand the concept. Thank you.